I was on stage.
Welcome. So we'll be talking about rotational motion in orbits. Circular motion is motion with a constant radius of a curve caused by accelerating being perpendicular to velocity. Axis is a straight line around which rotation occurs. Rotate, spin, circular motion around an internal axis. For example, the Earth rotates to cause a cycle of day and night. Revolve is a circular motion around an external axis. For example, a moon revolves around the Earth. The distance traveled by an object without a specific amount of time. Linear speed is directly proportional to the distance an object is from the center of rotational platform. Rotational speed, which is also known as angular speed, is the speed with which an object moves through an angle for every unit of time. Units are RPM, which is revolutions per minute. Radians per second. And period is the amount of time it takes to complete one cycle, which is a revolution. Centripetal acceleration is Newton's first law that states that a body in motion stays in motion at a constant speed and in a straight line unless acted upon by a net force. Therefore, a force must be pulling inward of an object moving in a circular path in order to prevent it from moving in a straight path. Centripetal seeking force is any force that acts on a right angle to a moving object's path and results in circular motion. Centrifugal is center fleeing force, which is a force not actually a force. It is a fictitious force that seems to pull outward of an object on a circular path that is due to inertia or a tendency for moving objects to follow a straight path. Simulated gravity is centrifugal force that can simulate gravity because from with a rotating frame of reference there seems to be a centrifugal force directed outward. Formula of centrifugal accelerations: A equals v squared divided by r, which also equals to 4 pi squared divided by t. Formula for centripetal force: F equals ma, which also equals m parentheses v squared divided by r.
Teacher,
yes.
Can I please correct that? Isn't that the first formula? Isn't it centripetal acceleration?
That is centripetal acceleration.
Oh, don't it point,
Dad. And torque is the tendency of a force to rotate an object about an axis. Rotational inertia, the resistance of an object changes its rotational state of motion. Rotational velocity is the rate of rotation around axes, expressed in radians or revolutions per second per minute. This is an example of rotational motion. As you can see, some key factors that involve in this is that acceleration is pointing over towards his finger, which is the center of mass, and tangential velocity follows path.
Mister, can I explain it?
Yes.
Okay, tangential velocity is always aligned with the curve. It's not with the curve, it's aligning with the curve.
Oh, correct.
Thank you, mister. I know I'm very smart.
The relationship used in this is the formula F equals ma, which also equals m parentheses v squared divided by r.
That's it? Okay, bye.
A 2 kilogram ball on a string is rotated about a circle of radius 10 meters. What is the maximum tension allowed in the string is 50 newtons. What is the maximum speed of the ball? So, to find velocity, we're going to use the formula of tension, which equals a force centripetal, which is mv squared over r. Now, in this problem, we're looking for speed. So we're gonna derive this equation so v will equal what we're looking for. So it will be v equals square root r radius tension over mass. So we're just gonna use this and just plug in what we already know. So velocity equals square root radius of 10, tension of 50, and a mass of 2, which will equal 15
0.8 meters per second.